Hi everybody, this is Mr. Rocco, and today we're going to be investigating the supercontinent called Pangaea. So we're going to be looking at the outlines of the continents, fossil evidence, rock evidence, and glacial evidence, and trying to see if we can put the pieces of the continents together like a puzzle. So we're going to start out by looking at our problem that we're going to be trying to solve. And our problem is, how can you use data from the continental shapes and the distribution of fossils and rocks to provide evidence of plate motions of the past? It says, if you've ever looked at a world map, you may have noticed that the outlines of South America and Africa seem to fit together like pieces of a jigsaw puzzle. Do you think this observation is a coincidence, or do you think the outlines of the continents might provide evidence that South America and Africa were once joined together? In this activity, we're going to explore the evidence for the past positions of the Earth's continents. So for this lab, we're going to need the map of the world handout. That's this document right here. You can download that right from Schoology. You're going to need some colored markers or crayons or colored pencils if you do this on paper, or you can just use your iPad in Notability if you're doing this at home and you're a distance learner and you're not able to print this out. You can simply do most of the assignment right in Notability. So our procedure is, I want you to study the world map. Notice the rectangles that are drawn on the map. Each rectangle shows a general area where specific fossils or rock formations are found. Notice that each rectangle also has a number on it. The number refers to the type of rock formation or the type of fossil found in the general area of the rectangle. Look at the map key below to identify which numbers correspond to each type of rock formation or fossils. So on this map, you're going to notice that we have different areas in the map that are labeled with a number. So, for example, this area has a number 1 on it. So this is going to represent the coal beds that are found across the world. Okay? This number right here has a number 3. We have a number 4 here. So number 3 and 4, number 3 is going to be another coal bed, and number 4 is going to be a folded mountain belt. So what we're going to do, the first thing you need to do is to pick a color for each of these different pieces of evidence on your map. We're going to color that in on our map. So our evidence that we have coal beds, folded mountains, the Glossopteris fossils, the Lysosaurus fossils, and the Mesosaurus fossils. And we're looking at where these fossils have been found and where these folded mountains have been found in these coal beds. And we're going to see if there's any sort of correlation between those different pieces of evidence on the different continents. So for my example, I'm going to use the color black for the coal beds because coal is black. So I'm just going to color in a black square here. And then what I would do is I would color in 1, 8, 9, 10, and 3. Okay, so I'm going to find those on the map. And if you're doing this in class, we're actually going to do this on paper. We're going to cut it out, and then we'll color it with colored pencils. But I just want to shade in. Oops, that's kind of big here. So I just want to shade in these areas so that I can use this to maybe match up different continents together. Okay, so that was 1, and I want to find 8. This is 1. And I think I wanted, was it 9? 9, 10, and 3. Here's 9. Here's 10. and then 3. Here's 3. So you would finish this first step by coloring in all of the different pieces of evidence, the different colors. So pick a color for each one that you want to use. So after that, the next step is step 3. After you finish coloring your map, cut out the continents along the coastlines. If you aren't able to print this off at home, you can skip that step, and instead of cutting out the continents, you can actually just kind of draw arrows to show where the continents you think would be linked together. And it says, try to arrange the continents so that they fit together. You may use the outlines of the continents as your guide. You may also use your color-coded rectangles as guides by lining up rectangles on one continent with rectangles of the same color on another. So we're going to see if there's a way to match up the color codes that we colored on our map and the shapes of the continents, and if we can use that evidence to put together the continents like a puzzle. So after you've accomplished that, like I said, if you are not able to print this off, if you're at home as a distance learner, you can just grab a red pencil, and what you can do is you can draw arrows to show where you think these continents are lined up together based on the color coding. So maybe, for example, you think that South America should fit into Africa right there. So you can draw a red arrow to show that. Again, it's going to be a little bit trickier if you can't cut it out, but you can still see if the shapes and the colors match up. And you can use the color coding and the shapes of the continents to try to see if they fit together like a puzzle or not. So after you've completed that part, you have some analysis questions. So I'm just going to talk about these because I don't want this video to be super long for you. But it says, number 1, look at your supercontinent. Which rock formations or fossils indicate that South America and Africa were once connected to each other? So if you're looking at your map, and we've talked about this in class, that it looks like South America does fit into Africa. And you can see that we have number 4 and number 13. So let's see what those are here. So number 4 was folded mountains, and 13 was folded mountains. So when we talk about folded mountains, we're actually looking at the rock type and the specific types of rocks that are formed, and the fact that they're metamorphic and folded. And we find that we have similar rocks in this area of South America and in this area of Africa. So that could be some evidence to help us think that South America may have been connected to Africa at one time. So if I was answering this question, I would say, which rock formations or fossils indicate that South America were once connected together? You could say the folded mountains match up on South America and Africa. Okay, next question. Select 2 continents that you join together other than South America and Africa. Come up with an explanation describing the evidence that indicates that these 2 continents were once joined. So after you figured out how the continents are combined together, I want you to pick 2 that are not South America and Africa and tell me about your reasoning for why you put them together the way you did. Number 3, look at your map. Notice that fossils of Glossopteris are found on Antarctica. Glossopteris is a fern. Glossopteris flourished in hot, dry climates. What does this characteristic suggest about the climate of Antarctica 245 million years ago? So we know that today Antarctica is a very cold place. It's one of the coldest places on the Earth, and it's found near the South Pole. And so the question they're saying is, if today it's very cold there, and we find fossils of this tropical fern, what could you infer, what could you suggest that the environment may have been like in Antarctica for that fern to be able to grow there? So clearly, the climate today is very different in Antarctica than it was when the fossil formed. Number 4. Look at your answer to the previous question. What does your answer suggest about the location of Antarctica 245 million years ago? So if you answered in number 3 that Antarctica must have been a much warmer place, a much more moist, warm climate, then how could that have occurred? So either the climate of the Earth was drastically different at that time, or Antarctica's location was in a different place than where it is today, possibly closer to the equator where it was warmer. So that would be some evidence to help support this continental drift theory that we're going to look more into. Okay, number 5. Lysosaurus has stocky bodies. The stocky form suggests that these animals were probably poor swimmers. Look at your map. Locate the areas where Lysosaurus fossils are found. Assuming these animals were poor swimmers, how do fossils of Lysosaurus provide evidence that the continents were once joined together, but later broke apart? So it's giving us some evidence that fossils that we're finding far apart are of a organism that, based on the structure of the fossils and the bones, we believe couldn't swim very well. And so how are we finding fossils of this organism on opposite continents around the world today? Could it suggest that they were together at one time? So I want you to think about that. Number 6, compare the distribution of the coal bed locations before and after you piece together the continents. So that was the black areas that we highlighted just a little while ago. How would you describe the distribution of coal beds in the current world map? How would you describe the distribution of coal beds in your supercontinent? So it's asking to see if there's any relationship between where the coal beds are today and where they may have been when the continents may have been connected together. Number 7, up until the mid-1900s, many scientists believed that the Earth's continents have always been where we see them today. Data such as evidence you have studied in this investigation begin to convince scientists that they needed to revise their theory. What information do you think scientists needed before revising their long-held theory that the Earth's continents do not move? So after going through this lab, you may or may not think that there is a fair amount of evidence that supports this idea that the continents were once in another location. But if you were a scientist back in the 1900s and you presented this evidence, and if you believe that this was pretty good evidence to help explain that the continents may have been at a different location in the past, what problem would other people have with believing that? So now you have evidence that can show the possible different location for the continents, but what are you missing? People are going to want to know, well, how would it be possible for a continent to be able to move? A continent that is literally a large chunk of our Earth. They would look at you and they would laugh in disbelief, unless you could have some sort of way to explain, well, how the continents are actually moving. Could you find evidence to prove that? And that's what piece of evidence was lacking when this first idea came about. So I want you to think about what other evidence would you really need, but beyond what we went over in this lab, to convince someone that the Earth's continents are moving. So what we did in this lab is we reviewed some evidence that real scientists collected back in the 1900s, and they used that evidence to come up with this theory called continental drift. And so we're kind of going through that same process that scientists did in the past. So if you have any questions, send your science teacher a message in Schoology.